Stanford University.
Welcome to Stanford CS193P, Developing Applications for iOS, Winter 2017. This is lecture number 16. We have some miscellaneous topics today, all of which I think might be interesting to you for your final projects. We're going to talk about alerts and alerts cousin action sheet. We'll talk about notifications. That's the radio station model from our MVC. We'll talk about the application lifecycle. We talked about the lifecycle of a view. Now we're going to talk about the lifecycle of the whole application. And finally, I'm going to talk about persistence. How do we store stuff so that when our app launches, it finds it? And of course, you already know a couple of ways of doing that, so I'm just going to show you a couple others. All right, let's start with this alerts and action sheets business. These are pop-up and ask the user a question kind of user interfaces. They're both just MVCs, alert and action sheets, just an MVC, and they're always presented modally or in a popover, which, as we learned last time, is basically modal. So alerts pop up in the middle of the screen. They usually ask questions with only two answers, like yes or no, okay and cancel. It is okay to have an alert, I guess, with just an okay button. So you usually want to maybe think if there's a better way to present that information to the user than putting up an alert. And then we start talking about having three answers in an alert. A, you might want to think about an action sheet, which I'll talk about in a second. And B, you just might want to think about, how am I getting the user into the situation where I'm asking them an emergency question and there's three different answers, or more, even more than three. That would really be interesting. So alerts are quite disruptive to the UI. User is happily using their user interface, and then bam, the whole screen goes gray, and there's this little box in the middle. It's giving them some alert. You really probably, I saw a Piazza post about using alert, and there was a great suggestion there from one of the TAs, which is, this is something you want to read the human interface guidelines about, using alerts, when to use them, what to say in an alert, things like that. And in fact, I recommend all of you read the human interface guidelines from Apple in general. So I'm going to post that on the class forum, the link to that. And I'm actually going to hold you to it in the UI part of the rubric in your final project. So pay some close attention to that. Apple has done a really good job of analyzing all the uses of the various UI elements and kind of what works well and what doesn't work so well and what's consistent between different things. So an alert can ask the user for a little bit of text. This has been abused to make like login screens out of alerts and things like that. It's pretty rare in my experience that you actually want to ask for text in an alert, but I'll show you in the demo today how to do it, but it's pretty unusual. And then there's action sheets. Now an action sheet does not gray out the whole screen and appear in a little box. Instead, on an iPhone, it slides up from the bottom, and on an iPad, it's always in a popover. Okay? Now, an action sheet I like to think of as a branching decision user interface element. So the user has gotten to some point in the UI where you simply can't really proceed without knowing what the user wants to do. So for an example is maybe you want to include an image in something, a contact, and it's the profile image or something like that. And do you want that image to come from the camera, where he's going to take a picture right now, or from the photo library, past photos are taken, or maybe from some collection view of clip art or something, avatars or whatever, that you provided. So you've got to kind of have to go one of these three directions. So an action sheet might slide up to the bottom and say, add photo, how do you want to do it? And you get these choices. And usually there's cancel also, which is, I didn't mean to do that, so cancel. Action sheets usually have more than two answers. It wouldn't be wrong necessarily to have an action sheet with only two answers, but it just rarely does that circumstance arise. So what do these two things look like? This is what an action sheet looks like on an iPhone. You see how it slides up from the bottom there, and it has some choices in it. And this is what an alert looks like. Takes over the whole screen. This one happens to have a little text field in it, and two choices there. So let's talk about the API to make these work, because it's the exact same API. In fact, it's the same MVC that does both of them. All right, and this is the API to create this view controller. It's called a UI alert controller. And it just has a title, which is that thing at the top. You see where it says redeploy Cassini in the picture on the left there. That's the title. And then message is just a short informational message telling the user what the heck is going on right now. And then preferred style right there. If you set that to action sheet, you get an action sheet. If you set it to .alert, you're going to get an alert. And I'll show you that. So the API for these is basically identical except for this one little preferred style thing right there. So once you've created your alert, you want to add buttons. Now adding buttons to your alert or action sheet is done with add action. And the argument to add action is a UI alert action object. And UI alert action is created with a title, so that's the title of the button, a style, and we'll talk about what all the styles, the button styles are, and then a handler. Now this handler is just a closure that you provide. This is the handler that's going to get executed if that button is pressed. So that's the model for alerts. Couldn't be simpler. So let's look at an example one. We got Orbit Saturn right there. See the title is Orbit Saturn. The style, this style is called .default. So the default style, the text is going to not be red, okay? It's going to be whatever color you've got going on in your app there, usually blue. And then in my closure here, this orbit Saturn, so I'm going to just go into orbit around Saturn. That's Cassini's mission, by the way, is to go to orbit around Saturn. So it's just going to do it, okay, if I click that button. And let's add another button. This one's Explore Titan, okay, a moon out there. This is a little bit outside, well, it's inside Cassini's mission, but before we divert it, we want to make sure we're going to log in, for example. So here in my closure, you see I've logged in, made sure I'm logged in before I go to Titan. But it's the same kind of thing, a default button right there. All right, so we got those two default buttons, the blue ones. How about that close-up of sun button? Now, if Cassini did a close-up of the sun, it would be destroyed because it doesn't have enough propulsion to escape the sun's gravity well there. So I've made the style of this button be .destructive as opposed to .default. And so .destructive in an action sheet is going to turn up red. Okay, just so the user knows, ooh, this one's probably something I have to be careful with. And anytime you have a destructive action in your closure, you're probably going to want to confirm that the user really wants to do that constructive action. In this case, for example, I'm going to make them log in again or something like that. So that's destructive. And then finally, we've got the cancel button at the bottom. That's another type of button called cancel style. And you can see that it looks a little different, right? It's kind of separated from the other buttons. It's not destructive. In fact, it's the opposite of destructive. It gets you out of the problem of this action sheet. Go back to wherever you were before. You're not really going to redeploy Cassini. And, but it is separated down there, kind of just to give it a little bit of a highlight. All right. All right, so I've added all my actions. I got my buttons, and now I want to make this action sheet appear on screen. And I do that with the normal method that I talked about before, which is present. Remember, present is a view controller method that just presents the view controller using whatever modal presentation style is set in that view controller, which by default is modal. Okay, so the action sheet slides at the bottom and it's being modally presented. So this is just modal present. That's what this is right here. And okay, so that looks good on the iPhone, but what about on the iPad? It would look terrible if if the thing was all the way the width of the iPad and came up, or if it was just tiny even in the middle, it would just look out of place right there. So of course on an iPad, we put this action sheet in a popover, and whatever button causes us to have to do this branching decision, that's the button that we're going to have the little arrow point to. So how do we make that work? Okay, because right now we're doing present this alert using the modal style, so it would come up modal on the iPad and it would look terrible. So instead, we just have to go and change our alert MVC, our action sheet MVC here, to have a modal presentation style of popover. Okay, and that means it's going to still present modal, but popover. Popover is basically modal, but different kind of presentation style. And of course, when it pops up, we want the little arrow to point at the redeploy button in my bar button item there. And so we're going to do that with that same popover presentation controller that we set the delegate of last time so we could control the adaptation, remember that, in the demo? And so we're going to use that same popover presentation controller. And this time we're going to set its bar button item to be the redeploy bar button item. And the popover presentation controller is smart enough to know, okay, I'm going to make my little arrow point at that. And as I said before, with the presentation controller, you could also have the little arrow point at an arbitrary rect in a view or at a button. Okay, so that's it. Now, what happens if we put this code in there, this alert modal presentation of popover, and we try and run, by the way, it should be lowercase p popover there, and we now try to run it back on the iPhone. What's it going to look like there? Well, it's going to look exactly the same as it used to. And why is that? Adaptation, right? It's going to adapt to the fact that in this case, we have a horizontally compact environment, and it's not going to put it in a popover. So that's automatic adaptation, same thing we had before. So it'll look fine. So if you have an app that's universal, you'll obviously put this little popover code in right there, and it'll look fine on your other device. So that's action sheet. What about alert? Same thing exactly. Basically, we're just going to say the preferred style is alert in this case. Here I'm going to add a cancel button there. I'm going to add a login button, okay? And I'm also going to add a text field to this one. So here's how I add a text field. I just say to the MVC, the alert MVC, add text field. Notice there's a little closure there that I can include to configure that text field. Set the placeholder text. Actually, this looks like a password, so I probably want secure text turned on in there, things like that. Probably would want to use trailing closure syntax there instead of using the whole thing, but I just wanted you to see the argument is called a configuration handler, because that's what it does. It configures the text field. You can add more than one text field if you want. And then the way you get the text out in your action, okay, this is so the login button's action right there. I'm going to get the alert and ask for its text fields, which is an array of text fields, because I said you can have more than one text field. I'm going to get the first one out of there, because I only have one. I could do at sub 0 and sub 1, whatever, depending on how many I have. And then I'm going to get the text out of it. All right, so now I have the text out of the text field, so it's really easy. Okay, so that's how the text fields work. Again, with alert style, we just present it modally. Now in this case, we don't present this in a popover on the iPad, so it looks exactly the same as on the iPhone, a little box in the middle, which is okay. It actually looks okay there. So nothing special to do in the alert case. So that's it. It's alerts and action sheets. I have a little demo and face it here, show you what this looks like. Code this up. All right, so here we are in Faceit where we were before, and watch what I'm going to do here. So here I'm pressing my add button here to do this nice editor MVC. What happens here if I just hit done? Oh no, it didn't work. That's weird. I'll try again. Let's try something like grin, squinting, done. I just made this work. What's going on? Well, actually, this did work. Because look, it added one right here. It's just the name was blank. Okay, I went up here, I hit done, and I didn't put a name, so it comes back. This is really bad UI because it quote worked, but this is clearly not what the user intends. For there to be blank lines there, they can't even tell the difference between there when there's something there or not. So really what we'd like is when we click done right here, we would like to put up an alert if you didn't give a name. Okay, and maybe we'll even put a text field in and let you type the name right there in the alert, which is a little questionable UI, but it's good for demo. Okay, so that's what we're going to do. So we're going to have this done button right here, put up an alert if the name field is empty. So how do we do that? Let's go over here to our editor MVC, the code here for our editor. Remember this code right here, pretty simple. And what I'm going to do, I want to prevent that unwind segue, the done unwind segue. I want to prevent it from happening if the name is empty, right? So how do I prevent a segue? What's the method that I add? I hear whispers of it. Yes, I think I hear it. Should perform segue. Remember that one? Should perform segue. So should perform segue with identifier. I'm going to implement that. And I'm just going to say if the identifier is my unwind. Does anyone remember what our identifier was? Let's go look it up so we can remind ourselves how we find it. So it was unwind out of here. Now, of course, we don't get to see our unwind segues as these little arrow lines. We had to go look in our document outline over here and click on this MVC and look at the bottom right there. Unwind segment, segue, add emotion we called it. Okay, if we click on an inspector, we'll see it. We called it add emotion. That's the identifier for that segue. All right, so now we know what our segue is called. Let's check it here. So if the identifier is add emotion, and if our name is empty, then we want to return false. Okay, we do not want to allow this segue to happen if that's empty. Otherwise, what are we going to return? Well, some people would mistakenly say, oh, return true. But you don't want to return true there. You want to return super should perform segue. Okay, because you want to give your super class a chance to, it might have some segues, and you want to give it a chance to see if it wants to allow this particular identifier. So don't forget that. Okay, when you're overriding these things, don't just return true there. Give your super class a chance. So let's run this just to see what this did. We haven't done any alert here, obviously. We're just preventing that done. We'll see if that even works. So here we go. It's add. Okay, I'm not putting a name in here. Done. And sure enough, it didn't unwind. See? But this would also be terrible UI. The user would think, oh no, delete this app. It doesn't work. Okay, this is a broken app. I'm clicking this button here. It's not doing anything. Forget it. So you never want to have a UI like that where you press a button and it just does nothing. That's really bad UI. So never do that. All right, so instead we want to do an alert. So I'm going to create a little function to put all this alert stuff in. Private func. We'll call it handle unnamed face. Okay, and in there we'll do our alert business. So I'm just going to do it up here. I'm going to handle this unnamed face when I'm still going to prevent this segue because I cannot do the segue when this name's empty. So I'm going to still return false, but I'm going to handle this unnamed face along the way here. Okay, so here's handle unnamed face. I want an alert. Easy. Alert equals UI alert controller. Here's the arguments down here. Title. Let's have the title be something like invalid face. And the message. There's a lot of good stuff in the human interface guidelines about messages here. Like you don't want to scold your user with these alert messages, okay? You want to be nice to them. So we just want to kind of explain nicely what's going on. Like we'll just say a face must have a name or something like that. Maybe even that's a little harsh, but we'll say we don't want it to be too long, but by the same time we don't want it to be too, terse and mean. So we're kind of somewhere in the middle. So we'll say a face has a name. And of course the style here, what is it? Is it action sheet? No, it's alert style. Okay, so I've created an alert. This is a view controller. This is returning. If I look at the type of alert right here, it's an alert controller, which is a UI view controller subclass. So I've got this nice thing. Let's just actually present this and see what happens. Let's go present, alert, animated, true. And we don't even need a completion handler. We rarely need that completion handler, by the way. It just tells you, okay, I've finished presenting this thing. If you want to do something, you could. So we present it. Let's go back here, go here. Again, I'm not putting the name in. Done. Okay, well, it's better. My app is still completely broken though because, whoa, I got this modal view controller up and there's no way to get rid of it. So my app is completely dead. The only way to get out of this is to literally kill the app. Okay, so we don't want that. We never want to have an alert with no buttons. Obvious. So let's give it a button. Go over here to our alert. Say alert.addAction, remember, is how we do that. And it's got a UI alert action. And let's look at the arguments here for alert action. We got a title. So I'm just going to put an OK button. I just got finished telling you that you really don't want to have alerts that only have one button, but this is a demo, so I'm just showing you how to add a button. Here's an OK button. The style of this one is a default. It's just a default button. It's not destructive or anything like that. One could argue this should almost be a cancel, but you're going to see that I'm not going to make it like a cancel here in a second. And then the handler, we're not doing anything when we click OK. So now let's run again. Oops, forgot a parentheses there. All right, let's run again. So here we go. We add, not putting a name, hit done. Comes up, invalid face. A face must have a name. OK. Now I'm back here. This probably is minimally okay. Right? This is probably fine. The user would immediately know, oh, I got to give it a name, and they'd go up here and give it a name. All would be well. But in order to show you text fields in an alert, how about when this comes up, if we give them a text field and let them enter a name? So they don't have to go back, enter a name, and click done. They can just type the name right here and click OK. So how would we do that? Well, one thing in our alert is that we would want to add a text field. Okay, and a configuration handler, we could configure this to do whatever we want. We'll just say we won't have a configuration handler here. And then in our add action, when the user clicks OK, I'm going to look in that text field, get the text out of it, and put it in my name field. Okay, remember that this handler gives you the action itself, the same alert action. It's kind of like if you had a delegate method, you get the thing that's delegating, same kind of thing here. This action right here would be passed to you in the handler. We don't need it though. I'm just going to say that my self.name text field, its text equals the alerts text fields, text. Actually, I guess that's all I need to do there. Unless, what did I, oh, not self-alert, sorry, alert. We've got our alert right here. Say that's this local variable right here. What do we, oh, text. A text field is an array. So let's grab the first one out of there and get its text. So this is fine, except for, look, we're presenting this thing before we add the text field. So that's not good. So let's put this down here. Try again. All right, go here, we're done. Now I have a text field in here. We'll say foo is the name we want. We click OK, and it puts foo in our name text field. Excellent. However, we're still making them go back and click done again, right? Because now I can hit done, and it works. Got this in here. But it'd be really nice if I go into this unnamed situation and I type something here and I click OK, if it would just do done automatically. So does anyone remember how we perform a segue from code? Because that's what we need to do. We need to perform that unwind from our code. I'm going to do it right here in my action handler. I'm just going to say self perform segue. Exactly what you would think. And the identifier, it's that add emotion, which is the unwind segue. And the sender, I don't really care who the sender is. I don't look at that in my prepare. I don't need it for any reason. Okay, that's all that's required there. It's a good chance for me to show you perform segue, segueing from code. All right, all done here. We go here. Let's do our favorite one, which is contentment right there. So I didn't put the name in here. Done. Face must have a name. I'll say content. We click OK. Comes back. Here it is. OK? Everybody got alert? Alert, pretty straightforward to implement. Action sheet is pretty much exactly the same way. No text fields, obviously, in an action sheet, but you just add more actions in that case. All righty, back to our slides. All right, next thing we're going to talk about is notifications. All right, notifications are the radio station in that MVC talk I gave right at the beginning of the quarter. This is how we can essentially broadcast information blindly to other objects in our application and have them tune in if they're interested. So how do we do this? The key to making notifications work is this class called Notification Center. So there is a default notification center which you get by accessing the static var called default on notification center. So you have notification center.default, gives you this default notification center. And so you can do two things once you have a default notification center. You can sign up to listen to radio broadcasts, or you can broadcast. Okay, those are the two things you can do. Super simple API, really, they did a nice job with this one. So first let's talk about how you sign up to listen. You want to listen to a certain radio station. It's done with this method that you send to the default notification center called addObserver. So addObserver means I'm listening to this radio station. And it has three arguments. The first one for name is the name of the radio station. Okay, now the type of that is nsNotification.name. I'm going to talk about that in a second, but that's just the name of the radio station you want to listen to. The second argument is object any. That's basically, in a sense, the sender, the broadcaster. If you're only interested in a radio station that's broadcast from a certain object, then you can put something there. If you put nil there, it means anybody broadcasting on that radio station, I'm interested. Okay? So it's just a way of narrowing down. The radio stations are kind of weird in that you can have multiple people broadcasting on the same station. Okay, it's not like a real radio station where it's only one radio station. And then the third argument is a queue. It actually has 4 arguments, I guess. The third argument is a queue that you're going to run this closure on. The fourth argument is a closure. So you sign up for this radio station, and when there are broadcasts, this closure gets executed. And that queue is what queue that closure gets executed on. If you say nil, by the way, for that queue, you'll get executed on the same queue that the radio station broadcaster is broadcasting on. But very often here you're going to be doing UI stuff, in which case you want to put operation.main queue here. Okay, operation.main I think is what it's called. Because you obviously need to be on the main queue to do any UI work. So inside this closure, you can see there's one argument, which is the notification. That is the broadcast packet, if you want to think of it, that was broadcast. And inside there's a couple of things, but the really important thing is something called the user info. You see that notification.userinfo? That's a dictionary that the broadcaster can put any information they want for people who are listening to this radio station. Okay, and we'll have some examples to see what kind of stuff people put in their user info. So that's it. Super straightforward. This is how you listen to a radio station. So let's see, before I show you an example of it, let's talk about nsNotification.name. It's typed like this, which is really nice and swift in iOS 10. They really typed all of the things that used to be just string have been typed, so you know what type of thing you're looking for here. nsNotification.name, what's really cool about that is if you go look at the documentation for nsNotification.name, you'll see all of the radio stations that iOS will broadcast on. And there's a lot of them, okay? But it's a great way to quickly learn what radio stations there are built into iOS. And they're all static vars. These names of the radio stations are static vars in nsNotification.name. Now you can create your own nsNotification.name because it's perfectly legal to create your own radio station and broadcast if you want. You just do that with the string initializer for the type nsNotification.name. nsNotification.name, hopefully by now you're familiar after reading your reading assignments and stuff. It's just a nested class. Name is just inside, it's a struct or something inside nsNotification, right? That's why it's nsNotification.name. Okay, so I'll talk about broadcasting in a second, but first I want to show you an example of listening. So here's a radio station, a system radio station called UI content size category did change. You see it there under the for name. And this, if you go into your settings app on your phone and go under accessibility, you'll see that there is a text size setting, looks like the thing on the right there, where you can set the size of your text. So when you get old, like me, you can make the text a little bit bigger and still see without having any reading glasses. When you're young like you can make it really small so you can get more text on screen. So when that changes though, all the apps find out about it, and each of them then locally broadcasts on this radio station. Now, radio stations are only used for broadcasting inside your app, so the communication from iOS, the operating system, to the apps that this changed is happening some other way. You don't know what it is, it's behind the scenes, you don't care. But when an app finds out that this slider has changed, it locally broadcasts on this radio station UI content size category did change, because that slider actually has like detente marks on there, and it's not just like the point size of the font, it's small, medium, large, extra, extra large, right? So that's as you slide that thing across. So if I want to hear about that change, now why would I want to hear that this is changing? I don't need to hear it for my fonts because I'm being a good programmer and I'm using the text styles in my UI. Remember when we went to the UI and we set the text style to be like body font or headline font or caption font? Remember when we were doing the little Twitter client there? So those will automatically get updated, okay, when this changes. But what if I have something else, an icon or some other image that really wants to size itself depending on the surrounding text? If the text gets really small, maybe the icon wants to get smaller. If the text gets really big, the icon wants to get bigger. So I might want to find out. So I find out by signing up to listen to this radio station with Add Observer, okay? And here I'm saying I'm only interested if the UI application object sends it. I could probably put nil there, actually, because I don't care who sends this. I know it's going to be the application object, but I don't really care. And I'm going to execute this on the main queue because I'm going to do UI things, for sure, in reaction to that size category changing. And then inside my closure, I look at the notification in the dictionary there. I'm looking for the key called UI content size category new value key. And I found out about that by looking in the documentation under nsnotification.name.ui content size category did change. And when I looked at that particular radio station, it said in the documentation, hey, you can use UI content size category new value key to get out of the dictionary the size category. In other words, the position of that slider. And so an example of what the value might be of that would be UI content size category small. Okay? So now I found out. And I'll find out every time that changes, I'll get a broadcast and it'll tell me. Now, I didn't really talk about this, but notice that add observer, that default notification setter method, it returns something. This thing observer, which is of type NSObject protocol, basically it's a cookie. Okay, you don't know what it is, you don't know what type it is. All you use it for is later, when you're no longer interested in hearing about this, you remove this observer. That's saying to the notification center, I don't want to hear about this radio station anymore, so don't send me any more broadcasts. Now, it's really important to do that. Okay, so usually we're going to do something UI oriented like this. In view did appear, we're going to add observer. And then in view will disappear, we're going to remove observer. Because it makes no sense to listen to this radio station and adjust our icon sizes and stuff when we're not on screen. Now, of course, this might happen while we're off screen, so when our view, perhaps in our view did appear or our view will appear, we might want to adjust our icon sizes based on this content size category, which you can get that from the UI application. You can just ask it what it is and it'll tell you. You don't have to get a radio station notification to find out what it is. All right, so that's an example of listening to a radio station. Now, what about sending on a radio station, broadcasting? Okay, that's super simple as well. You get that default notification center, and you're going to use the method post. Post takes the name of the radio station to post on, which again, you can invent your own if you want. The object, that's the sender, in case people might only be interested in this being broadcast from certain people. Usually this would be self that you would put there. But and then there's the user info. That's that dictionary that you get to pass to them. Okay, so that's the same user info they're going to get. So as soon as you execute this post, all listeners, all people who did add observer, who are listening for their closure to execute on the same queue as you're posting this on, will immediately execute. Okay? All the other ones, so if you're posting this off the main queue, for example, and your observers are all on the main queue, their closures will just be put on the queue. They'll be put on the main queue, and they'll execute the next opportunity that they have. All right? So that's it. Posting and posting to broadcast on the radio station. By the way, radio station, that's just something I made up. Nobody calls it that. You're not going to see that in the doc. It's just an analogy for what's going on here. All right, but that's notifications. There's another kind of radio station model thing which I'm not talking about, which is key value observing. And you might want to look that up in the doc as well. That's a way that you can sign up to find out if a var on some other object changes. Okay, so take a look at that if you might be interested in that. Okay, the next topic here is the application lifecycle. You know how we have a view lifecycle. We have an application 1, 2, and you get to find out as your application goes through its lifecycle. So first let me talk about the states that your application can be in. It can be in really one of 5 conditions. One is the top, not running. Okay, so that's the user has never not run your app. Obviously, you're not running. Okay, your code, there's no code executing in any way related to your app. No one's touched on your icon or anything. All right, then there's two foreground states after your app starts running. One is called the inactive state. In the inactive state, you don't get any events, you can't draw any UI, you're just kind of like preparing to really run. You're not active, you're not being shown on screen, the user's not interacting with you. The other foreground state is active. Now, this is the normal state where you're getting touch events, you're drawing on screen, you're interacting, the user perceives you as an active application. All right? Then there's also the background state. Now, the background state is even less running than the foreground inactive state. In the background state, you're clearly not on screen. And not only are you not on screen and interacting, you're barely running in the background and your lifetime there is limited. You're probably not going to run for more than 30 seconds. This is a transitory state between being in the foreground and going to the next state I'm going to talk about, which is to be suspended. Okay, so if you're suspended, no code in your application is running. You're still in memory, but you're just sitting there not running. You get no cycles. Now, one thing you have to kind of understand about how this lifecycle works is that you transition through these states in an orderly fashion. So when you launch, you go from not running to this foreground inactive state to active. You always transition through inactive to get to active. When some other app is switched to, someone launches another app, and you were the active app, you go from active back to inactive in the foreground briefly, then around down to background for up to 30 seconds or so, and then you get suspended, where you don't run at all. So you always transition through that flow to go from you're the active app to somebody else is the active app. Now, when you're in suspended state, and you get killed for whatever reason, you go straight to killed. No code of yours runs from the time you're suspended to the time you get killed. Why do you get killed? Well, maybe the user killed you explicitly. Maybe you started using too much memory and the system killed you. Maybe the phone's battery died. It got rebooted for some reason, whatever. So when you're in the suspended state, you kind of have to be ready to just be killed. So you wouldn't want to have any unsaved data or anything else going on in that state. That's why you get the background state to kind of get ready for that. Now, at each of these arrows, these orange arrows, you get a message sent to your application delegate. Okay, so far we've only used the application delegate to have our little core data stuff in there, but there's a bunch of methods in there. You've seen them every time you look in your app delegate, and we're going to talk about what they all do and when they're all called. So the first one in your app delegate is called application did finish launching with options. There's also a will finish launching with options, and it gives you this dictionary. Okay, in the dictionary, the keys are UI application launch options keys, which you can look in the documentation for that symbol, and you'll find all the various things that can appear in this dictionary, and the values depend on what the key is. By the way, all of these app delegate methods you can also get by listening to this radio stations. Okay, so the radio station for this one is the UI application did finish launching radio station, and it's notification.name.that. If you listen to that, you'll get, and you do add observer, you'll get your closure called when did finish launching happens. So you don't have to put it in your app delegate, you could put it in other places, other code. All right, now what happens here in this did finish launching with options? Why does it get called, things like that? Why do you have this dictionary? Well, obviously when you normally launch, this gets called, the dictionary doesn't have anything in it. Okay, because you just got launched normally. User clicked on your icon and launched. But there are a lot of other ways for you to get launched by the system. And when those other ways happen, then you're going to have this dictionary to tell you why and give you the information you need. So one thing, for example, is if your application opens a certain kind of document, let's say you're a PDF viewer and you know how to open PDF files and you've registered that with the system, then if someone in some other app says, oh, open this PDF, the system's going to launch you. And when it launches you, in the dictionary right there is going to be that URL with some key telling you to open it, right? And so that's an example. Another one is you can set up with core location. I didn't get to talk about core location this quarter, but you can set up with core location a mechanism whereby if you go by some place in the world, the dry cleaner is the canonical example, and you walk by the dry cleaner, your app will launch. Okay, so you can set that up, and if that happens, again, this dictionary will say, hey, I launched you because you went to one of your registered locations, and here's where you were. You can also do it for continuing activities. I don't know if you guys know about this feature. It's kind of a nice feature. You start browsing something on your phone, and then you switch over to your iPad. You can continue browsing from exactly where you were. Okay, so you might get launched to do that, to continue doing what you were doing. If you get a push notification, okay, we didn't really talk about notifications much. In the CloudKit one, I hope you all, how many of you saw the CloudKit Friday section? It's only a few of you. It's worth going back and looking at just to see notifications and push notifications. But if you get a push notification sent to you and your app is not running, it may get launched to handle that thing. Or if you have some Bluetooth device that you connect with, it gets in range and it gets launched. So there's a lot of reasons your application might get launched, and when it does, that dictionary is going to have the information related to that particular launch. Now, I'm going to warn you something. When you're doing your final project, you're going to be searching on the internet all the time to find ways to do things. And you might run across really old posts, which you can often tell because they're in Objective-C versus Swift. But if you ever see a post where someone in their application did finish launching with options is like saying UI split view controller init, okay, and navigation controller init, and they're building their UI in code right there, that's pre-storyboard code, okay? We do that stuff in the storyboard now. The times that we build any UI, an application did finish launching 0.001% of the time, okay? So I just want to make sure you don't get confused by that. So this little delegate method is sent with that arrow right there. You see the arrow that's down there? So that's the arrow where you go from not running into being inactive. Okay, so you're running, you can do stuff, but you're not on screen. So an application did finish launching with options. You could be building your UI, but you can't put it on screen yet. I mean, it won't appear on screen because you're still inactive. Now, I want to talk briefly about an opposite arrow there that can go into the inactive state. Okay, you can get into inactive from running, but you can also get inactive when you were running. Okay, and and things happen like you switch to another app, other things can happen that cause you to go back to the inactive state where you no longer can do UI. This transition, which is the will resign active transition, you want to think of as the pause button. This is where your app wants to pause. So if we were doing an asteroids app, I'd want to stop all of my asteroids, remember what their velocities were, okay, and be in a pause state. And then I'll show you when I'm going to unpause in a second here, and then put it all back. So this is pause. I like to think of this one as pause. You're going from being the active app where your UI is working to this inactive state. You're still in the foreground. Now, what causes this to happen? A phone call comes in. When a phone call comes in, your app kind of is in the background. You can't do any UI. It gets no events because the person's talking on the phone. But as soon as the phone call ends, you go back to being the active state. You never went into the background. You just were foreground inactive. Okay? Or you'll pass through this arrow on your way to the background. Someone did click on another app, and so you're transitioning back here. Still want to pause. And then you're going to go to the background. You want to clean up some more, because you might get terminated later. But here, it's worth pausing as you pass through here. So that's what the resign state is. Okay, this other arrow going in the other direction, this is when your app really starts up. Okay, so this is when your UI is available. Here's where you want to unpause. Okay, so if you have paused, then here's where you want to unpause, is in this did become active. All right, because you're going to pass through this on your way back from being in the background, or when the phone call ends, then you're going to go active. So this is the unpause. Now you are only unpause, obviously, if you paused. You never paused, then there's no unpause here. Okay, this little arrow down in the corner, this is the did enter background state. This is where you want to batten down the hatches, okay? You want to save any unsaved information. You've already paused, probably, because you went up through the active, so you can't get there from active unless you went through the inactive pause. See how the arrows go there? So here's where you want to save things. You want to get yourself in a state, you got about 30 seconds to do it, where you could be killed and the user wouldn't lose any data or anything. This is also a good place maybe to save your state a little bit. So if you did get killed and you got run again, you could start up exactly where you were. And there's actually some infrastructure in UI application, which I'll mention in a second, to do that. Okay, so this is the batten down the hatches area right here, the transition. When you come back out of the background, okay, so you were in the background or suspended, okay, when you come back out, you're going to get this application will enter foreground. Okay, so that's the thing that says, okay, you woke back up. This is where you can unbatten down the hatches. If you want to open some files that you had closed or something like that, you can do that here. Everybody got that? So these are the transitions you make through the lifetime of your application. The application delegate is involved in a lot of other things as well besides just the life cycle. For example, state restoration. This was the thing I was telling you just moments ago, where you can save your state so that when you launch again, you're in exactly the same state on the same view controller. Maybe even your first responder is the same blinking cursor in the same text field or whatever. You can save all that. There's a whole mechanism for doing that. Take a look at it if you want. Might be a good thing to get a rubric point out of in there. Also data protection. So the data on your phone is protected by default. When you're in the locked state, your phone is locked, then all the data on it is encrypted. So even if someone broke into the phone somehow and got the data out of the static RAM, it would all be encrypted, so it'll be useless anyway. So the app delegate can tell you when data becomes unencrypted and available for your use. In other words, unlocked, the screen has been unlocked, or when it goes back to being locked. You can open URLs in other apps. Okay, there's a method. I think one of the extra credit items, I think, or maybe we even made it as part of the required task of one. So you probably know how to do that. Oh, sorry, this is the other way around. This is someone's asking you to open a URL in the app delegate. Okay, and so this is you'll get this message to your app delegate saying, hey, some other app wants you to open this URL, and you can go do it. Similar to if you didn't get launched to it, because if you get launched to it, it's going to be in that dictionary, but otherwise you'll get this method. And there's also a whole mechanism for background fetching. Sometimes you might have an app that's a social media app, and you want to have up-to-date information for the user at all times so that if they launch, they're seeing the latest posts on your Facebook page or whatever. And to do that, you can set up this background fetching. Now, the background fetching is not happening once a minute or anything like that. It's happening, occasionally in the background. And if you try to do too much, the system will get upset at you and stop scheduling you so much. But what happens here in the background fetching is you move from the suspended state into the background state for 30 seconds or less usually, and you get to go fetch on the network or get your latest information, and then you go back to suspended. So that way, if you go suspended, background, foreground, active really quick, you've got the data. There's a few other things, but that's mostly what the application delegate is all about. Now, application delegate, of course, has to be a delegate of some object, and it's a delegate of UI application. So UI application is a class. There's only a single instance that you ever have in your app. You get it by saying UIApplication.shared, and it manages all the global behavior, which sounds like, wow, this is a really important object. But actually, it's not that important. You almost never interact with UI application because it delegates all of the interesting things to its app delegate. But there are a few things that you can do in UI application. For example, here's where you can open a URL in another app. You can register to receive push notifications here. Okay, push notifications, your app will not get unless you call this register for remote notifications in a UI application. By the way, notifications, push notifications and local notifications have been unified in iOS 10 into this UN notification framework. A push notification, you probably know what that is. That's when some server sends you some information, like in the CloudKit case, where it's telling you, hey, some data changed in your database. But local notifications are kind of cool as well. You can set up local local notifications that will fire at a certain time. That's how Calendar app reminds you when you have a particular appointment or whatever. It's using local notifications, and you schedule them for a certain time. I think you can also do local notifications for location changes. You get near the dry cleaner or whatever. So local notifications and push notifications are unified in iOS 10, and it's not part of UI application. It's this other framework. Unfortunately, I didn't have time to go over that. By the way, also, local notifications is different from NS notification, or just notification. Notification is that radio station thing. Local notification and push notification are this other mechanism for notifying the user, which is actually completely different, not related to each other at all. In application, you can also set the fetching interval for that background fetching thing I talked about. If you get into the background and you need more time, okay, 30 seconds is not enough, or something is blocking, or you need to get something from the network and you want some more time, you can ask for more time by asking the UI application object to begin a background task. Now, again, you can't abuse this. If you keep asking for more and more time and you're trying to run for 10 minutes, eventually the system's going to say, that's enough. Okay, this is for just exceptional circumstances where, I need another minute, please. Can I have some more time? And it'll give it to you as long as you don't abuse it. The little spinner in the upper left-hand corner of your device, okay, that spins. Have you ever seen that thing spinning when you do something on the network? You can control that. You can turn it on and off with this bool in UI application. You can also find out a lot of information, like remember that category size, little slider, text size slider. You can find out what the preferred content size category currently is. You can find out how much time you got remaining on your background, sitting in the background. You can also find which state you're in, foreground inactive, foreground active, background. You can find out which of those states you're in. So UI application's a little bit of a clearinghouse for that kind of global information. So that's it for UI application. Info.plist, we've already seen Info.plist. Info.plist is really like a raw data file that's storing a lot of your application settings. We saw the one where we had HTTP URLs and we wanted to allow those unsecure ones. Remember that, app transport security? We actually went and edited our Info.plist. You can see it looks like this when you click on it. This is a property list editor right here. So on the left-hand side, you can have strings and dictionaries and arrays, things that property lists are allowed to have. And on the right, you're going to have the values that are in there. This is really backing an XML file. Okay, this property list is stored as an XML file. You can actually right-click on it and edit it as an XML file. I strongly recommend against this because you can break this so easily. And then now the app won't be able to read this Info.plist anymore. So I recommend against doing that. But usually all these settings, you edit them in the project settings, right? You're not going to the Info.plist. There doesn't happen to be one, or at least I've never found one for that app transport security, but maybe they want it intentionally obscure because they want your app to be secure in that way. But you've seen many, many settings here, like do we allow portrait upside down and things like that. These are all stored in the Info.plist. Okay, so this settings UI that you see is pretty much an editor also on Info.plist for a lot of the things that you see there. Another thing that you'll see in your settings are capabilities. There are a number of features, a couple dozen maybe, that require an external server, okay, or some external resource like iCloud, right? CloudKit requires some server that's storing all that data out there, or Game Center has all the servers so that people can get together to play games and things like that. When you have that kind of thing where you essentially need your app to be authenticated so that the server you're talking to knows it's you, then you're going to have to go to the Capabilities tab in your project settings and turn it on. And turning it on basically means update my entitlement so that I'm entitled to do this particular thing. So see some of the examples up there besides iCloud and Game Center at the top. You have Apple Pay, in-app purchases. Obviously these things require servers and people connecting to them and things. Even the background fetching modes and things like that require some entitlements if you're going to be doing fetching while in the background. things like that. So check these out. This is a cool thing just to see what features there are out there. Again, maybe a way to add some breadth. Some of them are not that difficult to implement, simple versions of anyway. But you have to turn these on just to enable them. Yeah. Okay, my last topic here today is persistence. So persistence just means making data stay on the disk after your app is killed or dies. You already know about two really important ones: user defaults, which is tiny little pieces of data, preferences kind of data, and it has to be in property list format. And then there's core data, which is kind of the opposite, okay? Monster relational database, you can have huge data in there. It's really for data-centric applications where the data is what it's all about. So I'm not going to talk about those, you know about those. So I'm going to talk about these last three briefly. Archiving. So archiving is a way of storing an object graph that is not a property list on disk. Your storyboard is archived. Takes all those views, archives them to disk. So we'll talk about that. SQLite, you all know what SQL is. It's a relational database technology. iOS comes with kind of a light version of SQL, which you don't usually ever use because you're using core data. Core data is actually built on top of SQLite, but you don't have to access SQL directly. And finally, you can make things persist by putting them in the Unix file system. iOS got Unix underneath, so you can put things in that file system. We'll talk about how to do that. So let's talk about the archiving thing. Do not get the idea that this is a good way to have an arbitrary object graph that you have and store it on disk. Because archiving requires the involvement of all the objects that want to be archived. Each of them has to implement these two methods up here. Encode, which essentially takes your object and converts it into a dictionary. Okay? Not quite that, but that's 90% of what it is. So it converts it to a dictionary. And then it also has to implement this initializer. Any object that wants to be archived has to implement this initializer, which essentially gives you back that dictionary and tells you to create your object from it. Now, this is kind of special, this mechanism, because the system is smart enough to know when you put an object in your dictionary and someone else in the same object graph puts that object in there, that's the same object. So it's not going to ask that object to reconstitute itself twice. It's only going to ask it to do it once, and then it's going to make pointers to it. So this is how the storyboard can work. If you think about the storyboard, it's got a view hierarchy. All those views are pointing to other views in their subviews, but they're also pointing back to their super views. And obviously, you only want one copy of every view in that hierarchy. So UIView implements this coding protocol that has these methods in it, and that's why a view can be archived. And all the subclasses of UIView that come with iOS, like label and button, they also implement this. And that's why the storyboard can be archived. But I really, in the end, if you start having an arbitrary object graph and you try to implement this in code and init for all of them, it starts to be more work than, for example, just making a core data database to store that data in, or converting it to a property list and using user defaults if it's a small thing. All right? So people hear this and they're like, oh, that's cool. Yeah, I've got a big object graph of data and I'm just going to put it on disk using this. Well, it's a little more involved than you might think. And it also, you have to know what you're doing here to make sure you get those back pointers properly set up and things like that. SQLite, so this is SQL in a single file, one gigantic file, the entire SQL database. It's not a network thing, it's purely just a local file. SQLite is an open source project, comes with iOS. It's not really good for everything. I wouldn't store huge things in there. It's not really built for that. I'd probably put huge things in the file system. Even core data, when you create something big like an attribute that's an NS data, there's a switch in there you can turn on, which is store this in an external file, not actually in the database. And that's usually worth doing if the object's going to be fairly large. The API to use in SQLite directly looks like C, not surprisingly. It's not object-oriented in any way. It's just classic SQL call functions that you pass SQL language to, basically, and it executes it. And even though core data uses it, you don't see it from core data directly. The only reason you would probably use SQL if you had some existing database or something. The file system. Now the file system is something that I would imagine some of you might want to use in your final project. And your access to the Unix file system that underlies your application is a little bit limited. And so the way that you access it is generally these 4 steps. First, you're going to get a URL into the Unix file system. And there are about 20 preset points in the Unix file system that you can get a URL to. And once you've got that URL, then you can create directories there, create files there by taking your URL and adding path components to it to describe directories and files. Then you write to the files. You're usually doing this with a data object, or there's some property list methods that can write out to a file. And then finally, you're going to manage all those files with a class called the file manager. So the file manager lets you copy files and remove files and list files and directories. And all the things you can do with the file system, you do it with the file manager. So this is the main aspects of accessing the file system. So let's look at each of these things. It's a Unix file system. It starts at root. Of course, it's protected. There's permissions, so you can't go writing files into system directories or even reading a lot of the system directories. And we certainly can't see other apps, what they're doing over there. That's completely off limits there. In fact, you can only write and read inside what's called your application's sandbox. So the sandbox is this totally segregated part of the file system. It's the only place that you can actually look and do things in. Now, why do we have a sandbox? It might seem obvious to you for some things. For example, security is a big one. We don't want other apps to be able to reach into your app and damage you. Okay, that would be really bad. So you've got to have security for that. There's privacy. We wouldn't want those other apps to be able to look inside you and see your private data either. But another interesting reason that you wouldn't maybe think of is cleanup. If someone deletes your app from their phone entirely, they want everything this app has ever created to be gone. Okay? And by having the sandbox, and that's the only place you can write, when you delete, it deletes your entire sandbox. So anything you've ever created is gone. So you don't have to worry about people writing things into system directories and all that, which happens all over the place on the Mac, for example. Your home directory / library's got all kinds of junk in there. They don't have the same concept there of everything being isolated like you have in iOS. So it's actually a cool feature to have this sandbox. Now, inside the sandbox, there are certain directories that you can get a URL to. Like I said, there's about 20 of them. So for example, there's the application directory. That's where your application's binary is. You can only read in there, read only. You cannot write to your own application. No self-modifying code allowed, okay, in iOS. This is also where you might have things like JPEGs or other things. If you don't use the image assets things, you can actually just drag JPEGs or whatever directly into your project, and they'll appear in your application bundle. You can look at them directly. We rarely do that, by the way. But other URLs that you can look in there are kind of cool. There's the documents directory. That's a big one. That's where you're going to put user-created data that the user cares about. Okay? What the user perceives as their documents. Even if you don't have a document-oriented application, the user considers that as like, that's their data, that's what they entered. Now, your app might store that on the network, so maybe you don't have anything in your documents directory, or your app is just not the kind of app that has data like that, fine. But if it does, the documents directory is your primary place you're going to store stuff. But sometimes the user creates things and you're really just caching it. So for example, let's go back to our Twitter client that we write, smash tag. In smash tag, we downloaded images, and maybe we want to keep the images that are associated with the recents tab local. That way I can look at them even if I'm not connected to the network. But those aren't really user data. They're just something I want to cache. I just want to keep them local so for ease of use. But as things go out of recents, I probably clear them out. And if that cache directory got completely cleared out, it'd be fine. I'd just reload them all again. So the caches directory is a place to put stuff that you can easily get again. Okay? Images and stuff that you're caching. And there's a bunch of other directories. I don't really have time to talk about all of them, unfortunately. So how do we get our URL to one of these special directories, like the documents directory or the caches directory, things like that? Well, we're going to use this another default, just like we had NS notification or notification center.default. Now we have file manager.default. So the file manager is the thing that lets you manage the entire file system, and it has a default one that you can use. And it has a method called URLs for directory in domain mask. Okay, that's this method you see right here. And it gives you an array of URLs. In iOS, there's only ever one URL in there. The reason this is an array, on desktop machines like the Mac, sometimes you'll have like a library directory that has one for the user, one on the network, so there's multiple of them. But in iOS, all things are inside the sandbox, so the only domain, that's why the user domain mask there is always user domain mask. Okay, so there's only ever one URL. So there's only one URL for your documents directory, one URL for your caches directory, one URL for your documentation directory, one URL for your application directory, just one, because it's the one in the sandbox. So you specify which directory you want with that argument there for directory, and that has to be of type filemanager.searchPath directory. So again, look that up in the documentation and you'll see the various directories in your sandbox that you can look at. There's about 20 of them. And if you want the document directory, for example, you would say .document directory right there. And it would give you back an array where there's only one thing in there, it's a URL, and that URL is the URL you use to access your document directory in your sandbox. Make sense? So that's how we get in. Once we get in, we want to create directories in there, create files, whatever, or access files. We do those by using these appending methods in URL. So we have that URL, and we send a message to the URL like, give me a new URL by URL appending path component, whatever, the name of my directory or the name of the file that I want, or by appending path extension, so .jpeg or something like that, so I can get my JPEG file. So by doing that, I build a path, the URL, to the file I want. Okay, so that's how I navigate around in my sandbox. So now I have a URL, and I can do a lot of things with that URL. I'll show you in a moment how you can write files out and things like that. But you can also find out about things in the URL, like, is this a file or is it a directory? Or is it on the network, for example? Because you have a URL that someone gives you. Maybe it's a network URL, http:// something. Okay, well, that's not a file URL. So is file URL right there would tell you that it's in the file system. A really powerful method in URL is resource values for keys. So resource values for keys, you give it an array of keys that are attributes of files. These keys are attributes of files, like the file size or the file's creation date or whatever. And it will return you a dictionary with those keys and the values for the file, for the URL that you're pointing to. So that's how you can find out the size of a file or the creation date or whether it's a directory, things like that. Notice that this thing throws. So be careful here. You have to do this in a try. All right. How about writing files out to the file system? Well, mostly we do this with a data. Okay? If you have, for example, a UI image, and you want to store on your screen or whatever that you downloaded from the internet, and you want to store that into the file system, there's actually a cool function called, I think, UI image JPEG representation or something like that. And you give it a UI image, and it will return a data. And that data will have the data of that JPEG image, right, that you can store, and then you can say write to URL. So this is a data method here, write to URL atomically, and it will write it out to that URL. So you have to build yourself a URL by getting a sandbox directory and then appending whatever name you want to it. Then you say write to URL. Atomically just means it'll write it to a temp file first and then swap it in. So if you ran out of disk space while writing it or something, it wouldn't corrupt if a file that was already there, for example. Now, to get the data object back, you just use the same initializer you used when we did smash tag, or the lecture before that, where we said data init contents of URL. Now in that case, the URL was a network URL and it blocked the main queue. Here, that URL could be a file system URL and it wouldn't block the main queue. Okay? Loading files up super fast. So you don't really need to do that in a separate thread unless maybe it was a gigantic file, but even then, maybe you could do it. Yeah, question. When would you not want to do atomically right here? It's hard for me to even think of an example with that. Maybe it's a really huge file and you don't want to create 2 copies of it, right? The safe copy and then over. So you've got an existing copy of a huge file, let's say, and you don't want to create another copy of it as a safe copy before you move it in. So there you might say atomically no, so it just destroys your old one right off the bat. I mean, I'm really stretching to think of a good example. You almost always want true there. Okay, so that's how you read and write files with data. Very common way to do that. Once you've written out files, you want to be able to go through your file system and like look at what files are in certain directories or things like that. Maybe you've got caches out there and you want to see what's in your cache or whatever. And that's what File Manager is for. It has dozens of methods for doing that, like create directory at URL, which will create a directory for you so you can put files in there. And it also has it has a delegate and a bunch of shoulds. Okay, should I allow creating this file? Things like that, so you can kind of control how the File Manager works. The File Manager, by the way, is thread safe in the same way that an NS managed object context is thread safe. In other words, if you create the File Manager on a certain thread, then it's always thread safe to use it in that thread, in that same queue. Okay? If you create a File Manager on a different one, that one's safe to use in its queue, and they will work together as well. Just don't try and use a File Manager you created in one thread over on a different thread. That is not thread safe. Okay, it's just exactly like in this managed object context is thread safe. Okay, that is it for this lecture. So the coming up we have is accessibility is our next lecture on Monday, and also your slides are due for the alternate final there. Do not forget that. I put it in red. Okay. How many people, anyone here thinking they will be doing an alternate final? Okay, a few of you, so make sure you get your slides in. Wednesday will be the alternate final itself. Your final project is due the Sunday after that, Sunday the 19th of March at midnight. Okay, and that is it. So I will see you all on Monday.
For more, please visit us at stanford.edu.